On the screen, we have the diagram of a tandem scroll compressor configuration, with a lubrication system and common oil return to suction. Let's quickly go over its parts and how it works. 1. Oil separator. 2. Non-return valve. 3. Oil filter. 4. Oil equalization line. 5. Suction line. 6. Discharge line. 7. Oil return line. Now let's see how it operates. A. In this system, there are two compressors sharing a common oil separator. This separator functions to separate the oil from the refrigerant gas exiting the system. B. The separated oil is recirculated to the common suction line of the compressors. This ensures that the oil returns to the system for proper redistribution. C. Oil and refrigerant gas are fed back to each compressor from the common suction line. This ensures that each compressor receives the proper lubrication for its operation. D. It's crucial to maintain oil level balance between compressors. To achieve this, oil return must be evenly divided between operating compressors. E. Oil can return to the system as a mist along with gas and also as droplets along the length and curvature of the pipe. This means the system must be designed to handle different states of oil during its return. F. Since oil returns along with suction gas, matching gas flow is critical. Gas velocity in the suction line is crucial to ensure proper oil recirculation. G. The main suction line is connected to a suction header where suction pressures can be equalized. This helps ensure uniform gas flow and proper system pressure. H. When only one compressor is running, oil level in both compressors is maintained within the sight glass. The oil level in the running compressor is higher due to lower internal pressure. When both compressors are running, oil level is high and pressure is balanced. I. The cost of this system is relatively low, but it demands strict suction pipe design as well as strict requirements for oil equalization line sizing and suction header design.